Welcome to Video 11 Gadget Bootcamp. Today we'll cover: to trap or not to trap? That is the question. If we look at some of the gadgets I have been posting over the last several weeks, you will see that they contain very little error trapping. I fall into a situation of believing the user will always enter the correct information every time. Unfortunately, this is not the case. A well-designed error trapping strategy should not only prevent data issues, but guide the user to enter the correct value and data type. Today, I will review the same piece of code in 4 incremental steps, and applying a different error trapping methodology to prevent the occasional user meltdown. I have reviewed a gadget that I developed that parametrically draws the Maryland flag. Let's take a look to see how this works. Let's start with looking at what the trapped and the non-trapped error look like. This error here is a trapped error, and provides the user a message. This message is not of much value, but it is a message to the user. Here on line 497, the vectoric job function is called and returns the job ID. The if statement determines if the job is existing, ready for graphical input, and it is not. Therefore, the user sees this message saying, "No job found." Now we know what a bare minimum is. Now, let's create a job and rerun this gadget. The dialog is displayed. And we decide to cancel because I want to do something different. Now, the system is displaying a non-trapped error. This error is produced by the system, and provides the information as best the system can provide. You cannot guarantee the error is on line 224. Line 224 in this case, is showing where the error impacted the application. The actual error is located in the main function at the bottom of the code, around line 496. As I look at the code, it appears to be a logic issue. Line 503 issues a request from the user for the value of the flag height. By pressing cancel, we start a chain of issues. Let's go look at the request to see what it returns back. The function returns 0 when the cancel is pressed, and when the OK is pressed it returns the value in the display. This is a terrible way of retrieving information from a user. I wish I had caught this sooner. As I said before, I have produced 4 versions of this gadget, and now let's move to the second iteration of applying error trapping. My first action is to provide the user with clear instructions on how to address the first issue, no job found. The second action is to force a value greater than 1. If the user enters a 0, exchange it for a number 1. This is a very brute force method of bypassing the cancel/0 value problem. It is not recommended under any circumstance to force a value behind the scenes. So let's take a look at what this looks like now. As you can see, this dialog tells the user what the issue is and how to fix it. Now, I will add the file and rerun the gadget. Setting the value to 0, pressing OK. Produces a tiny version of the flag in the lower left-hand corner. This is very bad, and not the desired result. We should never produce something the user doesn't want in these gadgets. Because of the brute force logic, even the cancel produces the little flag in the bottom of the drawing. Even though we are not getting a non-trapped error, I would say this is totally unacceptable. Let's take it up a notch and see if we can avoid the little flag in the corner. This version has eliminated the little flag in the corner and is not displaying an error message. Let's try it with putting a 0 and the flag height and see what we get. Awesome, we are headed in the right way with this as type of error trap. Let's take a look at the code to see the logic on this strategy of error trapping. Here at the bottom, we are still using our verbose error trap for the no job found. Note the reverse logic of using the not method to invert true to false. And by encapsulated the draw flag function in a if statement to prevent drawing the little flag in the corner. And I would say this is an acceptable level of error trapping. But, it is not what we would call user-friendly. Ideally, if a user makes a data entry mistake, we should not dump all their work and make them start over. But, we should provide them a message on what the mistake was and represent the user screen so they can correct the issue. Let's look at a circular error trapping strategy. As we run the gadget, and setting a value of 30, we get a flag with the dimensions as desired. Let's clear that off and run it again. Now, when we enter the height of 0, we are presented a message that the value is unusable and must be greater than 0. On pressing OK, the user is presented the user interface to fix their mistake. This error trap will keep looping all day long until the user either enters an acceptable value or cancels. Running it once more, and entering a value of 30, no issue and we have flag. As we look at the code, we set a loop's value to true and proceed with a while loop until we set the loop's value to false. With a if statement examining what the user pressed OK or cancel. Inside that if, we examine the value of the data entered and if it is greater than 0 with OK, set loops to false and then draw the flag. Looking at the dialog, you can see I have altered both the OK and cancel return values. Regardless of OK or cancel, I update the global variable with the value they entered. And then pass back to the calling function a true or false. When the user enters an acceptable value and presses OK, we revalidate user inputs before proceeding to construct the flag. I believe, this circular approach to trapping an error is a much cleaner and user-friendly strategy. I am certain there are 1,000 different ways to approach this. I'm always interested in your method of dealing with errors and user interfaces. Any questions?